Good day, students. Welcome to Mathgotserved.com. In this clip, we're going to be going over section 2.3 of our virtual text for Algebra 1. We're going to be looking at how to solve multi-step equations. Before we get started, let's take a look at the types of solutions you can arrive at when you're solving multi-step equations. Okay, so types of solutions. There are three types of solutions that you can encounter when solving multi-step equations. The first type of solution you will get is a scenario where you have exactly one solution. Okay, so for example, you can have x equals a constant like 3. In this setup, you have a situation where you have a variable equal to a number, and that's your one solution. When you're solving multi-step equations, you can also have a situation where there are no solutions. All right. How do you identify no solutions? You have no solutions when you end up with a false statement. For example, you're solving an equation, a multi-step equation, and you end up with 2 equals 3. So is this a true or false statement? This is clearly false. Okay, so whenever you're solving equations and the variable disappears and you end up with a false statement, in that case there are no solutions. Alright, so the bottom line is false statement scenarios implies no solution. And then there's one more possible solution you can have when solving multi-step equations, and that's a case where you have infinitely many solutions, or some books refer to it as all real numbers. All real numbers. So anything you plug into that equation, any real number you plug into that equation will satisfy that equation. An example is 3 equals 3. Remember, when you end up with a false statement, you will have no solutions. And when you end up with a true statement with no variable components attached, in that case, you have infinitely many solutions, or all real numbers as your solutions. Okay, and this is a true statement. So look out for these solution types when we are solving the problems in this presentation. Alright, the instructions for the examples that we're working on are for us to solve the given equations. Okay, so solve the given equations. Alright, we're going to go through some examples, and after we're done with the examples, we're going to give you 6 problems to try out to demonstrate that you have mastered the contents of this presentation. Okay, question number 1. Let's say you have the equation -4 is equal to 7x minus 2 plus 5. Alright, so let's go ahead and solve this. Now remember, we have achieved the solved state when the variable is isolated. So the goal here is to get x by itself. Alright, to get started, we're going to combine like terms where possible. We can see that we have two constants on the same side, -2 and 5. Those two can be combined. So -4 equals 7x. Signs are different. You subtract and keep the sign of the bigger, plus 3. Okay. Now to get x isolated, we will have to move 3 to the left side of the equation and then 7 afterwards. So how do we go about accomplishing this? Now to undo addition, we use the inverse operation, which is subtraction. So we subtract 3 from both sides of the equation. Okay. When we do that, we end up with, what do we end up with? On the left side, -4 minus 3. The signs are the same, so you add and keep the sign. -7 is equal to 7x. And then -3 plus 3 add up to 0. Okay. Now to finish off this equation, we need to undo the relationship between 7 and x, okay, as multiplicative. So how do we undo multiplication? Or in other words, what's the inverse of multiplication? is division, right? So we proceed to divide both sides of the equation by 7, and then that gives us negative 1 equals x, and then we can rewrite it as x equals negative 1 using the reflexive property of equality. So that, ladies and gentlemen, is the answer to question 1. All right, let's take a look at the next example, number 2. What if we have the equation 2k minus 2k is equal to 7? Let's go ahead and solve that. So you have 2k minus 2k is equal to 7. Now to solve this equation, we have to combine like terms. On the left side of the equation, we have two like terms, okay? K, identical variables and degrees, so k to the first power. So what is 2k minus 2k? Since they're opposites of each other, when you combine them, you end up with 0. 0 equals 7. Is 0 ever equal to 7? The answer is no. This, ladies and gentlemen, is a false statement. Now, when you have a false statement, what is your solution? Is it one solution, infinitely many, or no solutions? If you have a false statement, the answer is no solutions. Alrighty, so keep that in mind whenever you're solving multi-step equations. Alright, let's go ahead and take a look at question number 3. Now, what if we have the following equation, the following multi-step equation? What if we have 2 times the quantity p minus 2 minus 5 is equal to negative 1 plus 6p. Let's go ahead and solve that. The solution is as follows. Okay, now when you see parentheses, a quantity with parentheses and a number in front, what operation comes to mind? What property do you have to use to get rid of the parentheses? You need to make use of the distributive property, okay? So you distribute 2 across p and negative 2, and your answer is going to be 2p minus 2 times 2 is 4. Okay, you have 2p minus 4 minus 5 is equal to negative 1 plus 6p. So remember, anytime you're solving equations and you have parentheses, you want to try and get rid of that by distribution as early as possible. Alright, now let's go ahead and combine like terms. Let's see, what do we have here? On the left side of the equation, negative 4 and negative 5 are like terms because they're both constants or they are 0-degree variables, so you can combine them. That yields 2p minus 4 minus 5. The signs are the same, you add and keep the sign. Minus 9 equals negative 1 plus 6p. So we're going to collect like terms to the respective sides of the equation. So what am I talking about? Well, we want the q's on the left and the numbers or constants on the right. So, or let's move the numbers to the right and then put the variables to the right and then the numbers to the left. It doesn't really matter, but you'll still get the same answer. Okay, so I'm going to subtract 2p from both sides of the equation. I just decided to put the variables on the right side because I want to see if I can save myself a step. So when we combine like terms, what will happen is that minus 2p plus 2p, these are opposites, they add up to 0. And then you have negative 9 equals negative 1. And then you combine these two plus 8p. So my goal was I was trying to maintain a positive coefficient for p to save us a step of that negativity there. So, alright, so there we have it. Now we're going to move 1, negative 1 to the left side of the equation. Minus 1, the inverse is plus 1, so you add 1 to both sides of the equation. If you add 1 to both sides of the equation, you are going to end up with negative 9 plus 1, the signs are different. You subtract, keep the sign of the bigger. Okay, so that is equal to, oh, quick correction. We have, this is supposed to be minus 2. So we have 6p minus 2p. 6 minus 2 is 4. So let's change that to positive 4. All right. Sorry about that. Okay, so that's 4p. Now we're going to add 1 to both sides of the equation. This adds up to 0. Okay, and then bring down the 4p. Now the last step involves getting p by itself. We'll divide both sides by 4. If we do that, divide both sides by 4, that will undo the negative p, the 4 in front of p there. So let's go ahead and do that. Divide both sides by 4. So divide by 4 and divide by 4. And what does that give us? Negative 8 divided by 4, negative divided by positive is going to be negative. So remember the rule. Anytime you divide different signs, you always end up with negative. Okay? So we have negative 2 is equal to the 4's divide each other out, which is p. And this is basically the same thing as p equals negative 2, using the reflexive property of equality. And that is the answer to question number 3. All right, let's take a look at 2 more examples. Now for the next one, let's look at this situation number 4. Let's say we're to solve the equation 3 minus 5 times 2 plus v equals negative 3v minus 3. Okay, let's go ahead and solve that. So the first question I like to ask is, what is the first step in solving this equation? Remember we talked about it earlier that when you have a parenthesis, you want to try and rid yourself of that as early as possible. So we can do that here. We have negative 5, so we can distribute negative 5 to 2 and distribute negative 5 to v. Okay, if we carry out the distribution, we're going to have 3 minus 5 times 2 is negative 10. Don't forget to distribute the sign. Minus 5 times v is negative 5v. And that is equal to negative 3v minus 3. We are now going to combine like terms where possible. On the left side, we have 2 constants that can be combined. So 3 minus 10, different signs, subtract and keep the sign of the bigger. Negative 7 minus 5v equals negative 3v minus 3. All right, now let's collect like terms. Let's place the constants on the left side of the equation and put the variables on the left and put the constants on the right. Let's do that. Okay, so I'm going to move negative 3v to the left side of the equation by using the inverse operation. Add 3v to both sides. And when you do that, you get negative 7. Now these are the signs are different, so you subtract and keep the sign of the bigger, which is negative. Okay, so negative 2v is equal to, this adds up to 0. And then just bring down negative 3. Okay, now we need to move the constants negative 7 to the right side of the equation since we decided to have the variables on the left. So we add 7 to both sides of the equation. And then our answer is going to become minus 7 plus 7, that's 0. So you have negative 2v is equal to negative 3 plus 7 is positive 4. And then to finish it off, we'll divide both sides by negative 2. And your final answer is v equals, now 4 divided by 2 is 2. Positive divided by negative, if the signs are different, you the sign is always going to be negative. Okay, whenever you're dividing or multiplying. So the answer to question 4 is negative 2. All right, let's take a look at question 5. Now, what if we have the equation 34 equals 4 times 8 plus 3b plus 2 times 1 minus 6b. Okay? All right, so if we take a look at this equation, the first question we want to ask ourselves is, what is the first step? What is the first step in this long equation to get the variable b isolated? Now, if you think back to previous problems when we had parentheses with number in front, the first move was to get rid of the parentheses as early as possible by doing what? By distributing, applying the distributive property. So we're going to distribute 4 to 8 and 3b, and we will also distribute 2 to 1 and negative 6b. So we have two distributions going on here in this equation. So that yields 34 equals 32 plus, that's 4 times 8, 32. 4 times 3 is 12 plus 12b. And then 2 times 1 is 2 minus 2 times 6, 12b. Okay? Now that we've got rid of the parentheses, we're going to combine like terms. If you look at the left side, the right side of the equation, we have multiple like terms that can be combined. We have two constants here, 32 and 2, that can be combined. So let's go ahead and do that. We have 34. 32 and 2, you're adding them, so you're going to have 34. Now, if you take a look at the variable terms, they are like terms too. Okay? So 12b and negative 12b are like terms, identical variables with the same degree. So we are going to proceed to combine them also. Positive 12b minus 12b, opposite signs, you subtract. And the sign doesn't really matter. So in this case, they basically add up to 0. So these two literally take each other out. We end up with 34 equals 34. What kind of statement is this? Ladies and gentlemen, this is a true statement. Okay, it's a true statement. So what does that mean? When you're solving multi-step equations, the variables cancel out and you end up with a true statement. There are infinitely many solutions. Infinitely many solutions. What does that mean? That means in this particular case, any real number that you plug into this equation will satisfy it. So it's either infinitely many solutions, or you can say all real numbers. Okay? Or all real numbers. And that is the answer to question 5. Alright, so how well did you master or grasp the contents of this presentation? To demonstrate mastery, we'd like you to try out the following problems. So what you're going to do is you copy down the problems, pause the video, and when you're done, you click on the playback button to see what the answers are. Okay? Instructions are to solve the given equations. Question 1, what if you had the equation 3 plus 5n plus 4 equals negative 8? Question 2, what if you have negative 6 equals 8a minus 6 minus 8a? Question 3, what if you have negative 3 times negative 8n plus 1 equals 165? 4, what if you have negative 6 times 1 plus 8a equals negative 246? And number 5, what if you have negative 8 times negative x plus 6 equals 8 times x minus 3 minus 4? And then lastly, what if you have 6x plus 3 times 6 minus x equals 6x minus 4 times x minus 4. Alright, so go ahead and pause the video and try out the following problems. We're going to be showing the answers momentarily. Alright, let's assume that you had the chance to try out the problems. The answers are as follows. So for question 1, n is equal to negative 3. For question 2, your solution is all real numbers. All real numbers, or you can say infinitely many solutions. Same thing. Number 3, n is equal to 7. Number 4, a is equal to 5. Number 5, you have no solution. And then number 6, you have x is equal to negative 2. Thanks so much for taking the time to watch this presentation. We really appreciate it. If you found the contents of this tutorial helpful in your studies of multi-step equations, do give us a thumbs up. Your positive feedback is very valuable to us. Don't forget to subscribe to our channel for updates to other presentations such as this. If you have any questions, comments, suggestions, just place it in the comment section below, and we'll be more than glad to respond. More clips and support tools can be found on mathgotserved.com. Do check it out. Thanks again for watching and have a wonderful day. Goodbye.